Hi, hello friends. Welcome back to tier revision class. So in the last session, we have been completed the basics of Fourier transform, and we left one more topic in Fourier transform, that is properties of Fourier transform. So let us start from there. But before that, you please confirm once whether do you have any problems? Can you all hear me? Am I audible? Hope you all can hear me. If there is any problem, please let me know on chat box. Okay. So in the last class, we have completed the basics of Fourier transform. We have been discussed about so many things. We have seen the properties, not properties we have not discussed yet. We saw how to transform the signals. If a signal will be given, we have seen so many signals. We have started from the scratch. We have been discussed about impulse, then we saw step function, cosine, sine, then from the duality property, how to write down the rectangular functions. We have seen so many things. Now it's time to discuss about the properties of Z transform. So let us discuss about the properties of Z transform. So this is the most important area. From here also questions will be repeatedly taken. So we'll be focusing on only two exams as of now. Only the first one is teacher recruitment board, and the another one is upcoming Barc exam. After completing these two exams, we will be focusing on other exams. Okay. So our syllabus is strictly related to only these two exams. Now, if we are focusing on properties of Z transform, the first one is, as usual, linear property. The linear properties of the Z transform, if you observe, suppose if I have a signal x1 of t, let us assume I have a signal x1 of t, and its correspondent Fourier transform, we can write x1 of j omega. If I have one more signal, if you are passing one more signal x2 of t, then its correspondent response or transform we can say that is x2 of j omega. Then on the output side, if you are adding these two signals together, whatever the response that you are getting, same response you will be getting when we are passing these two signals clubbed from the input side. If I am clubbing, after that if I am passing this output side, you will be getting same response. So again you will be getting x1 of j omega plus x2 of j omega only. So individually while taking a transform for two different signal, after that if you are adding them, you will get some result. Same result you will be obtaining. Rather before taking transform, first add these two signals at the input side, then take transform. So both resultants will be same. So that is the property of linearity. So in Fourier transform, this is how we are finding the property, that is how we are applying linear property for any type of signal. Anyway, let us enter into important properties, because linearity we will not be using much, but rather we must focus on the other signals, other properties. The first one is time shifting property. The first property that we are going to look at now is time shifting property. As we are observing, time shifting means what, sir? In Fourier series also we have been discussed about time shifting property. If I have a signal x of t, suppose, and its correspondent Fourier transform can be written as x of j omega. Now, if this signal will be shifted by an amount of, for an example, if I am considering x of t minus t naught, if I am considering x of t minus t naught, then its correspondent transform can be written as e power minus j times of omega. T will be shifted to t naught into x of j omega. That is called shifting property. But there are two types of shifting. This is delayed version. This version is called a delayed version. We can also perform advanced shifting, t plus t naught. If I am introducing t plus t naught, then this can be rewritten as e power plus j times of omega into t naught into x of j omega. So this is all shifting property, and that is how we have to apply shifting property when it is being asked in the examination. So the next most important property is conjugation property. As usual, we have also discussed this conjugation property for Fourier series. So let us discuss about the conjugation property for Fourier transform signals. So first, the next one is conjugate properties. Keep that in. So the next one is conjugate property. Sir, what is the meaning of this conjugate property? I told you, we have seen in Fourier series also same thing. For an example, suppose if I have a signal x of t. For this signal, its correspondent Fourier transform can be written as x of j omega. But in the examination, what they will ask is, if we are taking, if for x of t, Fourier transform is x of j omega, then what will be the Fourier transform of x conjugate of t? You can apply the same property, sir. In Fourier series also we saw the same. Two things will happen. One is, while taking conjugate, here we must take x conjugate under signature, that is sign of frequency also will change. So x conjugate of minus j omega. But if it is given that, the signal is a real signal, if it is mentioned that x of t is a real signal, if it is mentioned that the x of t is a real signal, then what will you write? In case of x of t, you should remember one more thing, that is x of minus j omega will be equal to, since it is given that real signal, x of minus j omega equal to x conjugate of omega. These both will give you the same result only when it is given that the signal is a real signal. So you have to remember the sum of the properties. Okay. The another most important property, whatever the things that I am giving here, all are very important. So you must be note down properly. So the next one is time scaling property. Note down. The another most important property is time scaling property of Fourier transform. Sorry. So the next most important property is time scaling property. What is the meaning of time scaling, sir? Suppose if I have a signal x of t, its correspondent Fourier transform is x of j omega. If this signal is scaled by the version of a, if I am having x of a times of t, then what can be the expected Fourier transform? If you have x of at, then its correspondent Fourier transform is 1 upon mod a into x of omega upon a. That is what we are writing. So here don't focus on this operator j. Sometimes it will be there, it is not there. Okay. So yourself you should assume that always that operator j will be there. Most of the time people will not be considering that operator here, because by default we know that things are standard. So this is scaling property. I would like to ask you one more question. Same thing I did for Fourier series coefficient. Suppose for x of t in Fourier series I am writing. For Fourier series in x of t, for x of t its correspondent Fourier series coefficient is, for example, let us take Cn. Then what is the Fourier series coefficient of x of at? X of at? What you'll be getting, sir? You'll be getting same. What I told, scaling property does not affect the Fourier series coefficient. Correct, na, sir? We have seen all other things are affecting. Time reversal, shifting, all those people are affecting the property of Fourier series coefficient, whereas scaling does not affect. Whereas in Fourier transform, that is not the case. This case will be different. Just a difference there. Find the difference between transform and the series, such that you can easily remember all these things. Okay. Let us go to the next property, that is differentiation property. Differentiation in time domain. So the another most important property is differentiation in time domain. Let us discuss about differentiation in time domain. Differentiation in time domain. Hope you all remember this. There also we have been discussed about the same property. Differentiation in time domain means, suppose I have a signal x of t. Its correspondent Fourier transform, what will be writing? X of j omega. Yes. If I am differentiating this signal with respect to time period, dx of t by dt, then what will be its correspondent Fourier transform? This is going to be j omega times of x of j omega. That is called differentiation property of a signal in time domain. Sir, you must remember this is very, very important. Now, this is one time differentiation. Suppose if you are doing n time differentiation, for example, if it is given d power n times of dx of t by dt, then what will be the answer? Dt power n. then its correspondent Fourier transform. This will give n times of coefficient. It means you can write j omega whole power n into x of j omega. Understand? So this is how we are applying time differentiation property. So it is very simple. In the question they will simply ask for x of t, its correspondent Fourier transform is they will give some values. Then they will do, if they are differentiating 5 times, then what will be the answer? One more question. If you remember the property, one step you can give your answer. But all you have to do is remembering the properties in a proper way. That is very important. Let's go. Sure. The next one is integration property. Differentiation is done. Next, integration in time domain. The next property is integration in time domain. Integration in time domain. Okay. See, what we are doing, integration in time domain means if I have a signal x of t, as usual, its correspondent Fourier transform can be written as x of j omega. Yes. If I am taking integration for the same thing, while taking integration, usually some dummy variable will be introduced here. What they will consider is they will be integrating this value from minus infinity to plus infinity, t up to a certain point. And here they will be considering some dummy variable x of tau into d tau. Then what can be the expected Fourier transform of this signal? That is very, very important property, because what it will give is x of j omega divided by j omega. But we are in Fourier transform. Along with that, we will also be considering initial condition. That is the most important question. Pi into del of omega into that initial value, whatever that they are giving, that you must consider here. Don't forget, this property is very, very important property. In order to register this in your mind, I will be writing it one more time. Whenever we are taking integration from minus infinity to t into x of tau into d tau, what will be the Fourier transform, sir? The Fourier transform. Just close your eyes and tell me the answer. X of j omega by j times of omega plus what will you write? Pi into del of omega into x of 0. Don't forget. That's why I'm writing 2 times. Okay, we should not forget, because this property is a little bit very important property. What we will be missing is the x of 0. Most of the time, the mistake repeatedly what you will do in the examination is you will be confusing what factor will come here. Delta of omega into x of 0. This factor will get confused to you all. I know this. So multiple times have a revision. Whenever you are considering this, you have to repeatedly observe. Okay, if I am taking integration in time domain, its correspondent value will be x of j omega by j omega plus pi times of del of omega into x of 0. Repeatedly you should recollect in your mind itself. Done, sir. Next, let us see the differentiation property in frequency domain. Next one, we have done the differentiation in time domain. So if I am performing the same differentiation in frequency domain, differentiation property in frequency domain. This is in frequency domain. Okay. See, if you are performing differentiation in frequency domain, what will be the answer? I will tell you first of all, what changes will happen here is, first thing, if I have a signal x of t, its correspondent Fourier transform will be x of j omega. Rather, if you are performing the differentiation frequency domain, d by d omega, if your signal has been differentiated with respect to omega, then what can be the answer that we can expect here? So we can write it in two ways, remember. So here it will become minus j times of t into x of t. That is the actual answer. But this can originally can also be written as, most of the time only t will be lies here. You will have to consider it. If I am considering the j in frequency domain, this will become plus j times of d by d omega into x of j omega. Sir, if we are performing multiple times differentiation, what I am trying to control, suppose if we are performing n times differentiation, then what will be the expected answer? If the differentiation has been done for n times, it means you will be getting n times, the t will be raised to the power of n. T power n times of x of t will going to be here also operator j will be raised to n times. For that you will have to perform the differentiation n times. So if you are performing the operation n times, then your answer is going to be operator j will be raised to n times, and of course the time t also will be raised to n times. Don't forget, sir, all these properties are very, very, very important properties. Direct one more questions will be framed in the examination. So you must remember these things. Okay. Next, the another most important property is frequency shifting. We have done time shifting. Let's perform frequency shifting. Keep that in. Next one is frequency shifting. So this is the another most important property. So what we are performing, what we are doing in frequency shifting, sir? In usual case, suppose if I have a signal x of t, then its correspondent Fourier transform I can consider as x of j omega. Undoubtedly this is correct. Now the shifting means shifting will be done in frequency domain, and we all very well know this. Same thing we have done in Fourier transform also. So here if I am shifting this signal j times of, no need to consider j every time. If omega will be shifted by omega naught, okay. So j will be common term here. So don't think about j. I am repeatedly saying in the examination they will not put this j. They will not consider this operator j every time. Okay. So if it is shifted by minus omega naught, then here it will be raised to the power of exponential, and there it is minus. Then here it will be plus j times of omega will be shifted to omega naught times of t. Along with it, you can consider x of t. If we are shifting the same signal, for an example, if I am having x of j times of omega will be shifted to plus omega naught. As usual, frequency shifting will always change the sign. So here it has been shifted by plus. So in advance, so here we'll have to consider minus j times of omega will be replaced by omega naught times of t into x of t. This is all about frequency shifting. Now we are entering into the most important property of Fourier transform. Repeatedly asked the question. Of course, that is the area in which most of you are, because of that property only you will be feeling that Fourier transform is completely what? Complicated one. But that is not the case. If you are very good in this property, you will be able to crack all the questions in the easiest way. So I will be guiding you. The another most important zone is duality property. The most important zone is duality property. So what is this duality property? Nothing. Duality will help us to shift a signal from time domain to frequency domain, as well as from frequency domain to time domain. I will tell you. For an example, if I have a signal x of t and its correspondent Fourier transform has been considered as x of j omega, simply I will be considering x of omega. Now, if you want to shift that signal from the property of duality, what we are going to do is this signal will be shifted to time domain. It means whatever the resultant answer that you are having for a signal in frequency domain, replace omega by t such that that signal will be reflected in time domain. If the frequency response of a signal will be lying in time domain, then its correspondent time domain response will be shifted to frequency domain. So while shifting the signal to frequency domain, you will have to consider two things. First, your signal will be multiplied by a factor of 2 pi. When we are shifting it to omega domain, your signal will be multiplied by a factor of 2 pi, and t will be replaced by minus omega. Two things you have to perform. One is t will be replaced by minus omega, and the second thing is it will be multiplied by a factor of 2 pi. So your resultant answer will become 2 pi into x of minus omega. That is the most important property, sir. I will give examples, don't worry. For an example, if I have a signal e power minus at into u of t, we all know its correspondent Fourier transform can be written as, how will you write down its Fourier transform, sir? 1 upon j times of omega plus a. Now, what they will do is, in the examination, what they will do is, they will apply the property of duality here. Rather giving this one, in the examination, what they will do is, find the Fourier transform of 1 upon jt plus a. What will be the correspondent Fourier transform of 1 upon jt plus a? When the moment you are observing this, most of you are feeling that it is too difficult. We cannot find the Fourier transform for such a signal. It is not at all being possible. So you will be definitely skipping this question. Don't do that. I will tell you. You can identify, just cross check. You know all the properties. You know the Fourier transform of e power minus at, e power plus at, u of t, del of t, cos omega t, sin omega t, t into e power minus at, t into cos omega t, whatever it is. You will have certain standard set of properties. No? We will have some standard set of Fourier transform. Yesterday I have defined everything step by step. Definitely they will frame the question from those one signal only. So now you know the Fourier transform of e power minus at, I know very well. So from this you can easily figure out that okay, they shifted this signal from time domain to frequency domain. So frequency domain to time domain. What they usually did, they took this signal, they applied the property of duality. Because of that, omega has been replaced by t. That's why it is lying here. So definitely what will be its correspondent answer? What you must know is, you should consider, okay, this is the duality property of 1 by j omega plus a. We know its correspondent value is e power minus at into u of t. What you have to do, just take this signal first, multiply the whole signal by 2 pi and replace t by minus omega. I told you, na, replace t by minus omega. If you do that, first it will be multiplied by a factor of 2 pi into e power minus a into t will be replaced by minus omega into u of t will be replaced by minus omega. That's it, sir. So your resultant answer will be 2 pi into e power plus a minus a into minus will become plus, na, plus e power a times of a omega into u of minus omega will be the final answer. Definitely it will be there in your option. You can pick it. All you have to do is understanding this, how to apply this duality concept. It's very simple, sir. You should remember all transforms, standard signals. U of t, what is the Fourier transform? Cos t, what is the Fourier transform? So you should remember all those. If you remember the basics, and especially the most important property is rectangular function, I will tell you, this type of questions will come. The repeatedly asked question in every exam is duality of rectangular function. As we observed that a into rectangular of t by tau can be written as, we saw its Fourier transform can be written as a tau into sinc of f into tau, or else we can also write a tau into sinc of omega tau by 2, omega tau by 2 pi. We saw so many factors. I am taking only one example. If we apply the transform property, I will tell you one more thing. This is written in terms of f, na sir. We were writing our properties in omega domain. So I will tell you in f domain how to write. I will be writing in omega domain. So in terms of omega, this can be written as sinc of omega tau by 2. I can write it as omega tau by 2. Yes, absolutely we can write. Or else you can also write down this. How will you write down, sir? This can also be written as, the alternative way is a tau into sinc of, tell me what is the alternative way? This can also be written as omega tau into 2 pi. So you must observe your option. Based on the option, you can choose the correct answer. Sir, now if you apply duality property for this rectangular function, what you will be getting? I will tell you. The answer for this function is, I am going with only omega domain, frequency domain. For the first one, I will write the answer later. In terms of f, don't worry. Now, for rectangular function, its Fourier transform can be written as a tau into sinc of omega tau by 2. I will be taking this one. Example. If I am applying the property of duality, then what will be getting? So I am going to write down this in time domain. To write down this in time domain, omega will be replaced by simply t. That's it, na sir. So your answer can be written as a tau into sinc of omega. See, omega will be replaced by t. So t into tau by 2. That is the duality of a rectangular function. What will be its correspondent Fourier transform? That is the most repeatedly asked question in the exam. You can observe. Because most of us are failed to understand this properly. Now, how should I find out the answer, sir? Let me do that. Take this function. How should I figure it out? If you are shifting any signal from time domain to frequency domain, I told you, replace t by minus omega, first thing, and your resultant answer will be multiplied by a factor of 2 pi. Now take the answer. So first thing, it will be multiplied by a factor of 2 pi. So 2 pi into rectangular of T will be replaced by minus omega by tau. But we also know one more important thing, that is we have studied from the basics. There are two types of signal. One is even signal and another one is odd signal. The properties of an even signal is, if I have x of t and x of minus t, the both are equal to each other in case of even signal. If I have an odd signal, then x of t can be replaced by minus x of minus t. These both are equal for an odd signal. If you are observing the properties of an even signal, this signal can be drawn. It lies between minus tau by 2 to plus tau. In frequency domain, the above signal can be written as minus tau by 2 to plus tau by 2 because the total width of the signal is tau in frequency domain, and its magnitude is 2 pi a. Its amplitude is 2 pi a. And if you observe left hand side, this is right hand side x of t, this is left hand side x of minus t, x of t both are equal. So this is even function. It means minus can be considered as plus. So you can put 2 pi a into rectangular of rectangular of omega by tau is the correspondent Fourier transform of a sinc function when it is given. Understand, sir? If they are considering pi also, see, I left one factor pi. If they are considering pi also, then nothing will happen. Just you can take pi will appear here. That's it. Either we can write it in terms without pi, or you can write it with the pi. Nothing will happen. Okay, so this is in terms of omega. Now I will give the duality property in terms of f. So duality can also be written in terms of f. I will tell you now. If I have a signal x of t, its correspondent Fourier transform in terms of f can be directly written as x of j times of f. That's it. If you are applying duality property, then as usual, this time f will be replaced by t, such that this function will be reflected here, x of j times of f will be replaced by t. Don't focus on operator j. Again I am saying it may or may not be mentioned in the question. Okay, because that is not mandatory. By default that will be there every time. Now what will be the Fourier transform, sir? If we are writing the duality property in terms of f, then factor 2 pi will not come. That will disappear. That's it. So rest of things are same. T will be replaced by minus f, such that the resultant answer x will be replaced by minus f simply. That's it. So what is the missing factor here? 2 pi is missing. Just 2 pi alone will not come. Rest of everything will fall in place. Now once again, let us take, if I am having example, if I am having a rectangular function a into rectangular of t by tau, then its correspondent Fourier transform can be written as a tau into sinc of f into tau. Now from here, if you are applying the properties of duality, what we have to do, sir? The first step, replace t by f. So the first step, replace f by t. F will be replaced by t, such that this can be written as in time domain a tau into sinc of f will be replaced by t, so t into tau. Its correspondent Fourier transform. If you will have a signal, in recent exam also this question has been asked in terms of f. So now its correspondent Fourier transform. What you have to do, sir? Factor 2 pi will be missing. Rest of things are remain same. T will be replaced by minus pi. But since the rectangular function is an even function, so that minus sign will disappear. So what you can say is, it can be written as a into rectangular of, I can replace t by minus f by tau. But all you have to understand here is, this minus f will be rewritten as plus f, because rectangular function is an even function. So this will become simply f by tau only. So what is the correct answer, sir? A tau into sinc of t into tau is given in the question. Its correspondent Fourier transform will be a into rectangular of f upon tau. So in the exam, directly what they will do is, just they will replace it by certain magnitude. And they will, for an example, if it is given f into sinc of 2 times of t, what will be its correspondent Fourier transform, sir? If it is given, first you should compare it with the standard signal. The things are, some certain things are missing here. What are those? If you are comparing this, here we have 4, na? In place of 4 we have a into tau, so I can write a tau equal to 4, first thing. And here t into tau we are having, so from this I can say tau is equal to 2. From this, the value of a, if you substitute tau equal to 2 here, sorry, tau equal to 2 here, 2 into a equal to 4, so a equal to 2. Now we found the value of a and tau, both are 2, 2. Now write down the corresponding answer. Its correspondent Fourier transform is going to be, value of a is 2, so 2 into rectangular of f by, what is value of tau, sir? Tau also 2, that's it, that is the Fourier transform. So you have to be very conscious whenever we are applying a duality concept. You have to be very careful how to apply this property. Okay, sir. Practice some questions that will give good grip on this. Okay, let's discuss about the another most important, that is convolution. Let me write down the convolution time domain. First, let us discuss about the convolution time domain, convolution property. So what is the meaning of convolution, sir? Two signals will be overlapping each other. They will be mixing. For example, if I have a signal x1 of t, its correspondent Fourier transform I can consider x1 of j omega. First one. Let us assume I am also having one more signal x2 of t, and its correspondent Fourier transform is as usual, that is going to be x2 of j omega. Now, if these two signals are involved in convolution, means x1 of t and x2 of t both are involved in convolution. x1 of t involved in convolution with the x2 of t. Put small t here, okay? Its correspondent transform. If two signals are involved in convolution, in time domain if they are in convolution, in frequency domain they will be in multiplication. That's it. So here what you will have to write is x1 of j omega will be simply get multiplied with the x2 of j omega. That's it, sir. So it is done. So this is all about convolution in time domain. So you have to be, this is also a very important property. So suppose if you are thinking, sir, if you are doing reverse means if the same two signals are involved in convolution in frequency domain. So you should remember, whenever we are performing convolution in frequency domain, a factor 1 by 2 pi will be introduced. It means I will be writing 1 by 2 pi times of, in bracket, if two signals are involved in convolution, x1 of j omega will be involved in convolution with the x2 of j omega. So if they are in convolution, its correspondent in time domain, your signal will be in multiplication. That's it. So x1 of t will be multiplied by x2 of t. Sir, in the examination, most of the time they will miss this factor 2 pi. They will not mention this. What you have to do? Suppose if this 2 pi factor is missing in frequency domain, then your answer can be written like this. In time domain, you should write 2 pi into x1 of t. It is in multiplication with the x2 of t. So its correspondent Fourier transform can be written as convolution. x1 of j omega involved in convolution with the x2 of j omega. Suppose, what is the another most important thing that you must observe here is I am writing everything in omega domain. If the convolution is given in f domain, then this factor 2 pi will not come. If it is written x1 of f is involved in convolution with the x2 of f, in that case factor 2 pi will not come. So if x1 of f involved in conversion to x2 of f, then directly you can say that x1 of t is simply in multiplication with the x2 of t. That's it. What will not come here? That factor 2 pi will not come. If you are writing the convolution in terms of f, you should remember that is very important. The another most important property like duality, where every one of you, most of you are failed to give the answer, is area under x of t or x of omega. That is also important area. So how should I calculate area under x of t or x of omega, sir? I will tell you. That is most important property actually. But you know, just by observing the question, you may not be able to predict. You should remember there is a concept is called area under x of t and x of omega. I will go one by one. So area under x of t. Very important property, sir. And most of you are not giving the answer for this very simple question. What property it is? How it is very important and how we are failed to giving the answer? First of all, Write down the formula. Area under x of t means integral of x of t. What is the meaning of this? Area under x of t means x of t lies. We are taking x of t. That's a certain signal and we are trying to find out the area of this signal. How should I do it? What they will do in the examination? They will draw a certain waveform. That waveform will be lies in frequency domain. For example, -2 to +2, a frequency domain value is given. It is omega domain. I am writing it is frequency domain minus omega, and the certain value will be given. This value is 5. Something will be given like this. You will be requested to find out the integral of x of t into dt. What you will be thinking now? The most important thing. Suddenly, what your mind will be thinking is, it is in frequency domain. Whereas they are asking the area in time domain. How should I formulate this? How should I write it in equation form? It is too difficult for me. It will be taking a lot of time and I am unable to solve this question. You will be skipping this question. But if you are saying its property, it is one step question. How should I give the answer for this? I will tell you. We know whenever you are trying to shift a signal from time domain to frequency domain, if I have a signal in time domain, how will you shift it in frequency domain? Every time I am writing x of t will be converted into x of omega in the form. For that, we will be having a standard formula. X of omega equal to integral of minus infinity to plus infinity. We will have a formula, sir. X of t into e power minus j times of omega t into dt. This is the standard formula. Yes, this is the standard formula that we are using. In this total interval, what is the comparison is, see, if you are comparing this with the area under x of t formula, if you are just comparing these two, what factor is missing here? The factor that is missing when we are comparing these two is e power j omega t is missing. Rest of every time period formula is there, x of t, x of everything is there. It means if I am comparing these two, the value of e power j omega t will become equal to 1. If I am making this value equal to 1, then this formula and this formula both will become same. How should I make it to 1, sir? For that, either I should replace a t by 0 or I should replace omega by 0. Which one is the best peaceful option here? You should replace omega by 0. Why? If you are replacing time by 0, then this entire formula will disappear. Time is there in the formula. Everywhere we are considering time. So time will must be not equal to 0. Make frequency omega equal to 0. So if you are writing, so this above formula can be written. If I am replacing omega by 0, then at omega equal to 0 point, whatever the things that you are getting in frequency domain, that value is equal to minus infinity to plus infinity x of t into e power omega 0 means e power 0. E power 0 value will become equal to 1. See that? How easy it is. Now what is the conclusion, sir? In time domain, throughout the interval minus infinity to plus infinity, x of t into dt, this total value will be equal to simply at omega equal to 0, whatever the value that you are having in frequency domain, that is the answer. Now go back to the question that I asked. See, in this question, this is the center point at omega equal to 0. What is the value of x of omega? This is x of 0 value. Sir, what is the answer? This is equal to 5. So this total answer equal to simply 5. That's it. See that? How easy it is? How easy it is? So you must know the property. This is area under x of t. Similarly, what they will ask is area under x of omega. Next type of question, what they will frame is area under x of omega. Now, let us take some question. For an example, there is one more signal has been given. Okay, and it is given that -2, 0, +2, something else. It is given in time domain. -t to +t it is running, and let's take this is 10, this is also 10, and it is given this is x of t. Okay, signal will be looks like a complicated one. Now the property what I told, area under x of omega. Write down the property is area under x of omega. So if this is the question, how should I solve? Wait, first write down the inverse Fourier transform property. Because if you know the inverse Fourier transform property, then only you will be able to give the answer. I will tell you what is the formula for inverse Fourier transform. X of t can be written as 1 upon 2 pi throughout the interval minus infinity to plus infinity x of omega into e power j times of omega t into d omega. Correct, na sir? This is inverse Fourier transform property. Area under x of omega means this can be written as throughout the integral x of omega into d omega is the meaning of area under x of omega. So when we are comparing these two, what is missing here as usual? E power j omega t is missing in the question. Question is area under x of omega. It means I will have to make this value equal to 1. It is possible only by making t equal to 0. Because we are in frequency domain, we cannot consider omega equal to 0. Okay, so the thing is, we will have to consider t equal to 0 if you are putting, then your answer will become c. Replace t by 0. X of 0 equal to, the answer will become 1 by 2 pi integral of minus infinity to plus infinity x of omega. What I did, sir? Replace the t by 0. So e power 0 value will become 1 into d omega. So from this what we can conclude? This formula. See, area under the integral, area under x of omega means only integral of x of omega into d omega. Something is missing, na sir? What is missing here? 1 by 2 pi will not come here. It means you will have to pass this value here. So the resultant answer will be 2 pi into x of 0 equal to integral of minus infinity to plus infinity x of omega into d omega. Correct, sir? This is area under x of omega. So whenever area under x of omega will be asked in the examination, what they will do now? They will give the graph for x of t. But in the question, they will be asking integral of x of omega into d omega. How will you give the answer? So you must observe at x equal to 0, this is x equal to 0 point. What is the value of magnitude, sir? 0. This is approaching to 0, na? So x of 0 value will be 0. If you are putting x of 0 equal to 0 here, the total value will become 0. So for this question, the answer will be from minus infinity to plus infinity, the value of x of omega into d omega, the value of x of omega into d omega will be equal to 2 pi into x of 0. Fortunately, the value of x of 0 will be 0. So the net value will be 0 for the given question. Understand, sir? So you must be very conscious that whenever this type of questions will be asked in the examination. The another most important property is Pascal energy theorem. Keep that in. The next most important property is Pascal energy theorem. Right now? 1 second. Yeah. So the next most important property is Pascal energy theorem. Pascal's energy theorem. So this is the most important property. So from Pascal energy theorem also you can observe questions will be repeatedly asked in the examination. So you have to be very conscious. So whenever we are applying Pascal energy theorem, just recollect once. In Fourier series also I wrote the Pascal energy theorem. What is the formula we saw? 1 by t integral of. So we have taken certain period because there it is periodic signal, na? 0 to t. What we saw? Mod of x of t whole square into dt. This is the formula to find out the energy. So here from this, so what are this? They will be dealing with the power. Okay, so the formula will become 1 by t integral of 0 to t x of t whole square into dt. After that, what will be dealing from here? Summation. Pascal theorem is from n equal to minus infinity to plus infinity mod of Cn whole square. This is the formula for Pascal theorem in Fourier series. In Fourier transform, what is the formula for energy? How should I calculate this? Let us see. For this, we will be traveling from once again. We are in aperiodic signal. So here you can consider the interval is minus infinity to plus infinity mod of x of t whole square into dt. So that is in time domain. Its equivalent value in frequency domain is going to be 1 upon 2 pi interval of, since we are in AP, we are traveling with the aperiodic signal. So the interval will be traveling from minus infinity to plus infinity, and mod of, as usual, we will be dealing with the, sorry, it is in frequency domain, mod of x of omega whole square into d omega. That is the property. You must remember this. And this can also be written as another way of writing this in F domain. This is omega domain. From minus infinity to plus infinity, mod of x of t whole square into dt. This is the energy formula. So here it is, factor 2 pi will not come if we are evaluating this in terms of f. If I am writing it in terms of f, then you no need to consider the factor 2 pi. Both are correct. In terms of omega, this will be like this. In terms of f, you should apply the Pascal theorem like this. Hope you all understand. So this is the most important property repeatedly asked in the examination. Okay, the another important property is time reversal property. Let us go ahead with the time reversal property. So let me observe. So what is the meaning of time reversal property, sir? Time reversal property. See, time reversal property means, suppose if I have a signal x of t and its correspondent Fourier transform is going to be x of j omega. Correct, na, sir? Time reversal means t will be flipped to minus t. Correct, na? So I will have to replace t by minus t. If you are replacing t by minus t, then its correspondent Fourier transform, what will happen, sir? Omega also will get flipped. So the value of omega also will become x of minus omega. That's it. So this is how we are applying time reversal property. That is a little bit most important property, and of course you must remember all these things when it is being asked in the examination. Hope you all understand. And for Fourier properties, I have also given some symmetric properties. See, when your signal in time domain, I have given few more things in the last class. Please recollect everything. If your signal is odd and real in time domain, then what will be its property in frequency domain? If your signal is even real, even imaginary, then this is in x of t. If your signal in x of t will be like this, what about its correspondent frequency domain property? Just recollect, in the last class, at last I have been discussed about these things. This is a most important property that is also repeatedly asked in the examination. If your signal is odd and real, then how should I explore this? If your signal is odd and imaginary, then how should I explore this? That is the another most important property that you must remember everything, sir. Whatever the conclusions that I made in the class, of course we are going at very short time period. Okay, because it is kind of revision class. Here I am unable to explore everything. You should understand what are the things. It is a revision class, so past revision. But I'm trying to cover everything. And see, agenda of this class is I would like to cover the total syllabus. Some portion you may be missed if you are preparing for TRP or if you are preparing for some other technical exams also. If you are doing self preparation now, it is very important to know whether you are covering all the topics or not. If you are missing each and every subject, if you are missing 2 to 3 topics continuously, what will happen? At last, that will leads to lose your mark. From each and every subject, if you are losing 2 to 3 marks, all put together, you will be losing 20 to 30 marks. Correct? Na? If 20 to 30 marks will go, automatically you will lose this seat. So it's very important to know whether you are covering all the properties of all the signals or not. That you have to be very conscious in that. Okay? Fine, sir. So hope you all understand all the things what are that I have given. Next, we will have to discuss about in the next class. We are going to discuss about discrete time Fourier transforms. In the next class, I am just giving intro. What we are going to discuss is the another most important area, discrete time Fourier transform. So there will be a difference. So continuous time and discrete time both are not same, and the formulas also we are not using same. So in discrete time we will be considering discrete samples. We will not be using the same one. So here these things will be completely different from the other things. So you must aware of discrete time signals. How should I draw? How should I compare it with the continuous time domain? How it will be different? How we are playing the integer values? So there are so many things to discuss. We will be dealing with all these things in the next class. Till then, whatever the queries that you are having, you can see, you can also have a discussion with our group members. We will have a Telegram group. Now go to our website www.rkelectricalgrid.com. There you can find all the things. You can find all lectures accumulated together. Under TRB test series also we have around we have been launched 230 small tests, quizzes, subject wise test, chapter wise test, because this test has been formulated in order to cover the total syllabus in the questions itself, and you'll get the complete grip on the subjects. So just visit once and try to after. See, it is very low cost. Almost it is free of test only. We cannot give it for free now. You have to at least do some compensations for this. So just it is very less cost only. You can buy the test and try to complete whole test before going to the exam. That is very important. It's not like 230 test means if you are writing one or two, you may not be able to cover the whole syllabus. You should complete the whole test such that you will get the complete. You will be able to cover the whole syllabus. Whenever you are getting doubts in questions, just to have some form a small group on WhatsApp or Telegram. There are so many groups are available. Join in that group, update all the questions, discuss with them, get it as all your doubts should get sorted out, and make a clear notes. Whatever the things that you are learning new now, you have to make a short notes. So the new concept should be there in a short notes, and you have to repeatedly revise all those things. Okay. Okay, sir. This is all for this lecture. We will meet soon in the next class. Till then, bye bye. Thank you all.